Hi, in this video we are going to talk about naive pattern searching algorithm. Before we talk about the algorithm, let's first see the problem. The problem is we are given a text and a pattern. We need to find all indexes where this pattern occurs in the text. So if your text is AB, 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 CD and your pattern is AB, AB, you can notice that this pattern appears at index 0, right? It's present here, AB, AB. It also appears at index 2, AB, AB, right? And at other indexes 3, 4, 5, 6, 7, it does not appear. So our output is 0 and 2. In this example, our pattern is ABCD and our text is ABC, ABCD. Now it does not appear at 0 because 3 characters match but the 4th character does not match, right? ABC are matching but A and D do not match. So it does not appear at 0, it appears at index 3, right? So we write output as 3. It matches here completely. A matches with A, B matches with B, C matches with D, C and D matches with D. This is an interesting pattern. You have all A's in the text, you have all A's in the pattern. So in these cases, your pattern appears at all valid indexes. It appears at index 0, appears at index 1, appears at index 2. After that, it's not possible because only 3 characters left. So output is 0, 1, 2. It appears at all indexes 0 to 2. And if your pattern does not appear in the text, then you don't need to print anything. Now please pause this video and try to write down a function that takes a pattern as an argument, a text as an argument, and this function prints all the indexes where this pattern appears in the text. Let us now talk about naive pattern searching algorithm to solve the problem. The idea of naive pattern searching algorithm is really simple. We have a text and we have a pattern. We need to find all indexes where this pattern is present. So what we do is we slide this pattern over the text one by one. We first compare these 4 characters with these 4 characters and then we slide it and compare these 4 characters with the pattern. Then we compare these 4 characters with the pattern and then we compare these 4 characters with the pattern. Now how does the sliding happen? We are running an index I equal to 0, I smaller than equal to n minus m. How do we get this number n minus m? See, the indexes here are 0, 1, 2, 3, 4, 5, 6 and here are 0, 1, 2, 3. What is n? Number of characters in the text. How many characters we have in the text? 7. How many characters in the pattern? 4. Now, how long we will slide it? We will try it at index 0 with these 4 characters, then at 1, then at 2, then at 3. And what is the last index that we try? 7 minus 4. So 7 minus 4 is the last point till we run this loop and I is the starting point of the current window in the text. So when we are at window starting with index I, we compare characters of the pattern and text one by one. And if all characters match, we print that particular index. So here is C++ implementation and this side we have Java implementation. You can notice in both the implementations, we are running a loop for I equal to 0, I smaller than equal to n minus m, which is a starting point of the current window. Then to match individual characters, we run a loop for j equal to 0, j smaller than m, j plus plus, which means we are matching all the characters of the pattern with all the characters of the current window of the text. And at any point, if we find a mismatch, we break the loop. And if all characters match, if j becomes m while you are matching the characters, then you print that particular index of the text that we found the pattern at this index. Now let's understand this code with this example. We have I equal to 0, j begins from here. Now j equal to 0, j smaller than m, match all the characters. So j equal to 0 matching, j equal to 1 matching, j equal to 2 matching, j equal to 3 not matching. So we break the loop. And when we broke the loop, j was not equal to m. What is m? M is 4. J was 3, right? So what we do now? We begin the next iteration of the outer loop. When you begin the next iteration of the outer loop, you begin with I equal to 1. So what are you going to do now? You are going to slide the pattern here. You're going to begin comparing the current window of text with pattern at index 1. So A and B, they are compared, they do not match. So you come out of the loop for j equal to 0 itself. Since j is not m, you don't print that index, right? So you now come here, A, B, C, D. Again you come out at index 0 itself because these two are not matching. then you move the window to next character, your next iteration of the loop for I equal to 3, and this is the last iteration. Here you again match the characters, j equal to 0 matching, j equal to 1 matching, j equal to 2 matching, j equal to 3 matching. So all the characters are matching. You come out of the loop because j became m. So when you come out of the loop and if j is m, then you print that index. So you print the output as 3. Pattern found at index 3. That's the simple idea. Take the pattern, slide it over the text one by one and compare the characters, and at any point if you don't find a match, then current window cannot match, right? And you can notice the indexes j is 0 to m minus 1 every time we start matching from the beginning of the pattern. And in the text we are using the indexes I plus j because I is the starting point of the current window and j is the shift from the starting point. So this is how this naive algorithm works. Now talking about the time complexity of this naive algorithm, if you take a look at this algorithm, we have a loop that runs n minus m plus 1 times, right? 0 to n minus m. So it runs n minus m plus 1 times in the worst case, and multiplied by, actually there is no worst case, it's always going to run at n minus m plus 1 times. So it's always n minus m plus 1 times this outer loop is going to run. This inner loop is, worst case will run m times for every shift, and you will have m times for every shift in the worst case. So an upper bound on the time complexity is n minus m plus 1 into big O of m into m. And when will the worst case happen? Imagine this is string, the last example that we talked about. When you have all A's in the text and you have 3 A's in the pattern. What will happen here? When you start from this window, they 3 will match. So this loop will run all 3 times. Then you will shift it here. Again, all 3 characters will match, right? So this will run m times. Again, all characters will match. So it's going to run exactly m times for these kind of examples, right? So in the worst case, this is the time taken by this algorithm. So I've used big O. It's an upper bound. It might take less than this because it doesn't have to run m times every time. Now talking about auxiliary space, it takes big O of 1 auxiliary space. Please note that naive pattern searching algorithm is not the best way to do pattern searching. It's quadratic time algorithm, and there exists linear time algorithms which can search a pattern in a text. And these algorithms are KMP algorithm, Z algorithm. Even Rabin-Karp is better than naive, although Rabin-Karp is also quadratic in the worst case. We'll talk about these algorithms in the upcoming videos.